Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with different subjects ranging from biology, physics, chemistry, and mathematics. And of course, we're going to see that we are going to find in one way or another some application areas that we're going to do in terms of a problem set in some of our videos. So in this particular case, we're going to look at an aspect of geometry, and that is how we can be able to distinguish between rays, angles, and what we refer to as planes. And this, of course, are going to assist us in trying to interpret various areas that we come across, especially in mathematics and sciences, that is going to deal with the aspect of rays, angles, and the planes, especially on the coordinate systems and description of some of the aspects of motion and points in space. Now, in our earlier discussion, we had said that basically the aspect of geometry deals with the science of space, and this is, of course, going to be more profound in some of the application areas that we're going to give sorry for that, in terms of our problem set. Now, if we can recall from our last discussion, I said that we can be able to describe what we refer to as a point, or just give a notation for what we refer to as a point using that specific notation. And I said that a point is basically an infinitesimally small location in space that can be given in terms of that specific notation that given as such. And then secondly, we say that we can be able to describe what we refer to as a segment, which is going to be the description between two endpoints given as A and B. And of course, we had given a notation for line segment using that specific notation over AB with this specific bar at that specific point. And then lastly, we talked about the concept of a line. And we say that a line is of course going to constitute of a segment that is going to have of course these lines or these endpoints extended infinitely in both directions. And we can be able to give an example of a line segment AB, which is going to have this section of the endpoints extended infinitely on both directions. So therefore this is going to constitute a line, and we can be able to give a notation for a line as AB using that specific symbol that is showing the extension of those two specific endpoints. So therefore, from this one, we can be able to describe what we refer to as array. And of course, array is going to be part of a line which is going to, of course, start at some point, perhaps at one point of A, and it's going to extend in one direction. So therefore, we can be able to describe array in this specific set. So we have said it's part of a line. So it can be a line for a point, endpoint A, B, and then it's going to extend infinitely in one direction. And therefore, we can as well describe this one as a point AB, which is going to extend in the opposite direction in that specific set, two sets of illustration. So this, therefore, is going to constitute what we refer to as array. And we can be able to describe array, as I've said, is as part of a line or a line that is going to extend infinitely in one direction. And of course, we're going to have a different notation for a line. In our case here, we're going to have AB being given in that specific description. And of course, the second one is going to show extension of this specific towards the endpoint of A. Therefore, we're going to describe this line as BA given as such. So kindly be taking note of these specific illustrations that we're going to give, so that in any case we give it in terms of a symbol, then therefore it's going to be comprehensive for us. Now there's going to be one of the characteristics that we're going to note, which is going to be the difference between segment and array, and that is in terms of their description. We have said that we can be able to describe this specific segment given as AB. So AB can as well be described as BA using that specific notation. But if we try to look at this one, we're going to see that the direction of extension is going to be opposite. Therefore, we're going to see that there is one of the characteristics that we can be able to use in distinguishing this aspect of array is that the ray AB is not going to be equivalent to the ray BA given as such. And this is basically due to their difference in direction of extension that I've given above. So therefore, I presume that we can be able to, or I'm going to hope that we're going to be able to differentiate between array and a segment and one of their characteristics that I've mentioned above. Now from this aspect of array, then therefore we are going to describe what we call an angle. And an angle is going to be given as, of course, an illustration that consists of two rays which have a point that we're going to refer to as, just give this one, we're going to refer to this one as a vertex. And if this vertex is point P, then therefore we're going to have Q and R given as such. And therefore, this is going to constitute of two rays that have got a common point P. And the area that is, or the point of extension between these two specific rays, then therefore is going to be referred to as an angle. Therefore, let me just describe it as theta. So therefore, the theta is going to be what we refer to as a description of this, of course, a description of this merging of these two rays which are extending in those specific direction, and the extension in between, then therefore is going to be referred to as an angle. So we can be able to describe as an angle as the joining of two rays which have a common point, and in the particular notation, we can be able to give this one as angle. So we're going to use this specific notation for an angle, and we can be able to describe an angle in terms of a notation as angle QPR, or in this specific case, still we can be able to describe this as angle RPQ given as such. So in this notation of an angle, we are going to see that there's going to be a specific characteristic whereby the vertex or this particular common endpoint is going to appear in the middle of this specific description that we have given. So therefore, whenever we're going to write this particular aspect of an angle, we're going to see that the vertex should always be appearing in the middle of those specific points. So therefore, I presume in our areas of application of this aspect of geometry dealing with angles, we're going to take note of that specific characteristic or that specific statement that we've mentioned about the vertex or the middle point. So therefore, from this aspect of angles, then therefore we're going to look at an aspect that we refer to as a plane. And a plane is going to be basically a flat region or a flat surface that is going to extend infinitely in four directions. And in our illustration, since we cannot be able to just have an illustration for an infinitely extension of a surface in four directions, I can just be able to give a portion of a plane using these specific notations that I've given on the board. So therefore, this is going to constitute of a region or a flat region that is going to be extending infinitely in four directions. And we're going to use, to show this particular notation whenever we're going to use what we call a drawing or some sets of geometry in the Cartesian coordinate systems. So I hope that from this video we can be able to distinguish between a ray, angle, and a plane from these particular discussions that we have had. So catch us in our next video as we're going to look at a different aspect of trying to measure these specific angles. And perhaps we are going also to look at some of the aspects or new terms that we're going to come across, especially on perpendiculars and bisectors. So that is it for now, guys. Bye. Catch us in our next video.